Personalized nutrition is rooted in the concept that one size does not fit all, and who doesn't want to think they're special? The concept of personalized nutrition is inherently appealing to the human ego. Simple messages recognizing individuality therefore resonate deeply with consumers, explaining the popularity of such messages in sales and marketing, even to the point of manufacturing personalized food for people's uniqueness, suggesting 3D food printing is a good candidate for food customization. Now, there certainly are some legitimate differences between people. Some have a peanut allergy and keel over if they eat a peanut, and others have celiac disease and have to avoid gluten, or genetically are lactose intolerant. There's an enzyme mutation common in some parts of Asia that protect against alcoholism, because people with it can't metabolize alcohol as efficiently, so toxic metabolites build up. I did a fascinating video about fast versus slow caffeine metabolizers and the difference in health benefits. That actually extends to athletic performance. Caffeine is ergogenic, performance-enhancing, but only in fast metabolizers, shaving more than a minute off 10 kilometers of cycling, whereas slower metabolizers got no benefit, or caffeine actually slows them down, adding 2 minutes to their cycling time, depending on which kind of genes they have that codes the enzymes that breaks it down. But for most people, in most situations, we are more similar than different. While there's undoubtedly a specific minority of individuals who clearly require a more personalized approach to nutrition, there is presently insufficient rationale for truly personalized nutrition for the majority of people. Yet there's an astonishing number of direct-to-consumer genetic testing companies that have proliferated offering personalized nutrition advice. For example, supplement-hawking companies claiming to help consumers optimize micronutrient status on the basis of a handful of genetic variants. But the majority of these variants explain just a few % of the difference in levels between individuals. Personalized nutrition is part of a broader push towards personalized medicine, also known as precision medicine, given the massive cultural allure of personal control over prevention, diagnosis, and treatment of disease, stimulating demand and prompting intense commercialization. But unlike monogenetic diseases, which are rare genetic diseases caused by a single malfunctioning gene like hemophilia or sickle cell anemia, most diseases are caused by a complex interaction between multiple genes with environmental factors, which pose a major challenge for the realization of personalized medicine. Take something like adult stature, for example. We've found at least 40 locations on our chromosomes that have been associated with human height, which is strongly inherited. The genes from your parents account for about 80% of the difference in height between people. Yet all those dozens of genes we found explain only about 5% of height variation between people. Researchers find those genetic links by using what are called genome-wide association studies, where you scan through all the chromosomes and look for statistical associations between diseases and any particular stretches of DNA. OK, that's interesting, but what companies marketing genetic susceptibility tests are doing is reinterpreting these data as if they were predictive of individual risks. But all you're really getting are modest genetic associations with a slight increase in the risk of disease, and with little predictive value when compared to more significant contributions of things we already know, like lifestyle behaviors. Currently, the practice of utilizing the DNA of an individual to predict disease has been judged to provide little or no useful information. For example, let's say your genetic analysis says you're at slightly greater risk for some grave condition compared to others in your ancestral group. This person was given advice to exercise, keep their weight down, not drink too much alcohol, and eat fruits, vegetables, and whole grains. OK, solid advice, but this is how we should live regardless of our genetic risk. And we all know, or should know, these simple bedrock strategies to reduce the risk of common chronic diseases in general. The problem, of course, is that very few individuals live that way. Actually, to be more precise, almost nobody lives that way. That's not just hyperbole. Nationwide surveys show that nearly the entire U.S. population consumes a diet that is not on par with even the wimpy dietary guidelines recommendations. In other words, almost no one in the United States is eating a healthy diet. Studies like that remind us that, from the perspective of public health, worrying about personalizing our preventive strategies based on genetic risk information borders on the absurd.